In this session, we are going to talk about motion in a plane or two-dimension motion. In this case, a particle moves from point A to point B in XY plane. At any instant of time, the particle location is P, which is given by x, y. X is the displacement in x direction and y is the displacement in y direction. The position of P can be given by position vector OP, and position vector R can be represented by xi cap plus y j cap in the form of components in x and y direction, where x is equal to r cos theta and y is equal to r sin theta, which is a component of r in y direction. And here the magnitude of position vector is given by square root of x square plus y square, and the direction is given by tan inverse y by x. Now for the same motion of particle, the velocity at point P can be given by the tangent at that point, and this is represented by velocity vector v, which makes an angle theta with x-axis. Now this velocity vector has two components. One is vx, which is in x direction, and another is at perpendicular y direction. So v can be represented by vx I cap plus vy j cap, and where vx is v cos theta and vy is v sin theta. Similarly, in the same way, the magnitude of v can be represented by vx square plus vy square under root, and the direction of v is given by tan inverse vy by vx. Now what about the acceleration? The way we have given the position vector, the velocity vector, similarly we give the acceleration vector. And the acceleration vector can be also presented in its component form, where ax is the x component and ay is the y component of acceleration. So we have seen that the position vector, the velocity vector, and the acceleration vector can be presented in its component form. So the motion in a plane can be considered as a combination of two rectilinear motions along x and y direction. Along x-axis the displacement is x, and along y-axis the displacement is y. Now along x-axis the velocity vx is given by the rate of change of its location or position in x direction, which is equal to dx by dt. Similarly, the vy is dy by dt. Now the acceleration along x-axis is the change in velocity in x direction with time, which is dvx by dt. Similarly, the acceleration along ay is dvy by dt. Now this acceleration can be presented as a second derivative of its position. If acceleration is a function of displacement, then this will be equal to dvx by dt. You just multiply with dx and divided by dx. So dx by dt, which is this one, is equal to v, and this formula becomes dv dvx by dx, and that is this formula. So whenever the acceleration is a function of position or displacement, then we use this formula to solve the problem. We will understand it more when we start doing some of the numericals based on different scenarios of motion in a plane. Example 1. In this, the position of particle is a function of time, and we have to find out the displacement, velocity and acceleration at time t is equal to 1 second. We know the position vector can be represented in form of its component. Here the position vector r is equal to x I cap plus y j cap, where x is the component of position vector in x direction. So if we compare these two equations, we know that x equal to 4t and y is equal to 3t square plus 2t. So displacement in x and y directions both are time dependent. So at time t is equal to 1 second, the x is 4 meter and y is equal to 5 meter. So the displacement of particle at t is equal to 1 second can be given by the magnitude of displacement vector, which is equal to square root of x square, which is 4 square, plus y square means 5 square, and that is equal to square root of 41 meter. Since displacement is a vector quantity, so we need to find out the direction as well. So direction of the displacement is given by theta, which is tan inverse y upon x, and here theta is the angle between displacement vector and x axis. So this is equal to tan inverse 5 by 4. So this way we can find out the position or the displacement of the particle after 1 second of travel. Now let's get into the velocity portion. A velocity is defined as the rate of change of displacement with time. So that is dr by dt, and this is equal to 4 I cap plus 6t plus 2 j cap. Here v equal to vx I cap plus vy j cap. When you compare these two equations, the vx equal to 4 and vy equal to 6t plus 2. So the x component of velocity is a constant 4 meter per second, and the y component of velocity is variable with time. Okay, so at t is equal to 1 second, the vx will remain as 4 meter per second and vy will be 8 meter per second. So the magnitude of velocity can be given by the square root of 4 square plus 8 square, and that is equal to square root of 80 meter per second. Since the velocity is also a vector quantity, so its direction is given by theta equal to tan inverse vy upon vx, and theta is the angle of velocity vector with positive x axis. Here this is equal to tan inverse 8 by 4, which is equivalent to 2. So here the magnitude of velocity is a square root of 80 and the direction is tan inverse 2. Now let's move to the acceleration. So acceleration A is given by the derivative of velocity with respect to time. In the previous part of this question, we have found out the velocity vector 4i plus 6t plus 2 j cap. So acceleration can be written as 0i because derivative of any constant is 0, and this is equal to 6j. So the acceleration component in x direction is 0 and y direction is 6 meter per second square. So it means the particle is moving with a constant velocity in x direction and with an acceleration in y direction. So if you compare this equation with axi plus ayj, you will get ax equal to 0 and ay equal to 6 meter per second square. So acceleration in this case is only unidirectional in y direction. So magnitude of A is 6 meter per second square, and its direction is given by theta equal to tan inverse ay upon ax, which is 6 by 0, and this is equal to tan inverse infinity, and that is equal to 90 degree, which we already know because acceleration has component only in y direction. So if you have position vector as a function of time, you can find out the velocity of particle at any instant of time as well as the acceleration of the particle. Okay, now let's move to the example number 2. In this case, the velocity of particle is a function of time, and it's given that the position at t is equal to 0. In the start, the position was x equal to 0. Now we have to find out the displacement after time t is equal to 1 second. And v0, f and g are constant. So here velocity can be written in the form of displacement dx by dt. And this is equal to v0 plus gt plus ft square. Or we can say dx equal to v0 plus gt plus ft square dot dt, and if we integrate both the sides, so integrate from time t is equal to 0, then at that time x will be equal to 0, which is given, and time t is equal to t second, the displacement let's consider as x. So in that case, x will be equal to 0 to x limit, and here the integration of this is v0t plus zt square by 2 plus ftq by 3. And here this will be 0 to time t. So once we open this, we will get x equal to v0t plus zt square by 2 plus ftq by 3. So for time t is equal to 1 second, if we put this value, we will get a displacement of v0 plus z by 2 plus f by 3. And that is what the answer is. Example 3. In this, a car starts to move in a straight path from station A to B with an acceleration which depends on the position of the car. So here the car starts from A and it will go to B with an acceleration which is dependent on the position 4x, and the displacement is 10 meter. For example, let's take B is 10 meter away. So we have to find out the velocity at B. Initial velocity is 0. So in this case, since acceleration is a function of x, we have to use formula a v dv by dx. And this will be equal to 3 plus 4x. Or we can say that v dv equal to 3 plus 4x dx. And now if we integrate both the sides, x is changing from 0 to 10 meter, velocity changing 0 to v. So we can say v square by 2 0v equal to 3x plus 4x square by 2, and this will be 0 to 10. So this will give you v square by 2 equal to 30 plus 100 into 4, or here you can do 2, so 2x square. So 10 into 10 is 100, into 2 is 200. So this will give you the velocity magnitude, which is equal to 320 into 2 means 640 square root meter per second. And that is what the velocity of the particle at a displacement of 10 meter from its starting point. And since this is a straight line motion, so it will remain in the same direction. And now it is a time for question for you. In this question, the displacement is given as a function of time, and you have to tell at what time the particle will come to rest. And that's all we have for today's session. I hope you would have enjoyed it. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.